Good day, girls. Welcome to our lesson on finding the equation of a curve. Let's first start by reviewing the fact that whenever you integrate a function with respect to x, you get its integral function plus a constant. That will be our main idea that we use today, along with some basic reasoning to figure out how to determine the equation of a curve. So let's get right into it with an example and let's start to work some examples. Let's say we know that the gradient of the tangent at a point on a curve is given by x squared plus x minus 2. Find the equation of the curve if it passes through the point 2, 1. So let's look at this and see what we understand from what is said. If it is the gradient of the tangent at a point on a curve, in other words, that is our gradient function dy dx. So we know that dy dx is equal to x squared plus x minus 2. Now, if our derivative dy dx is equal to x squared plus x minus 2, how can we use that to determine the equation of the curve itself? Well, when you're asked to find the equation of the curve, basically all you're asked to find is what is y equal to in terms of x. What is the equation of the curve, in other words, right? So if we were to integrate both sides of this with respect to x, right, the integral of the derivative, right, the integral of dy dx will just be y. How comes do you just get y? Well, remember that the integral and the derivative are the inverse of each other. So you can think about it this way. If you have your function y is equal to whatever it is in terms of x, when we found the derivative of that, we got dy dx. And since integration is also known as the antiderivative, it is the reverse process. If you were to integrate dy dx, then you will get back y. So that's why this is y. So when we integrate now, then what's the integral of x squared? That would be x cubed over 3. What's the integral of x? That would be x squared over 2. And what's the integral of negative 2? That is simply minus 2x. And what is left here? Plus c, plus my constant. So I almost have the equation of the line, right? The equation of the curve, sorry. The only thing missing is this c. How can I find that c? Well, I know that my particular equation passes through the point 2, 1. So if it passes through the point 2, 1, then my x value is 2 and my y value is 1. So I can substitute these in place of x and y into this equation and then solve for c. So let's see what we get when we substitute these values. So y is 1 and x is 2. So we'll have 1 is equal to 2 cubed over 3 plus 2 squared over 2 minus 2 times 2 plus c. So simplifying, I have 1 is equal to 8 over 3 plus 4 over 2 minus 4 plus c. Simplifying further, I will have 1, then 8 over 3 is 2 and 2/3. When I transpose it, it will be minus 2 and 2/3. 4 divided by 2 is 2, so when I transpose, I'll have minus 2. Instead of subtracting 4, when I transpose, I'll add 4, and that gives me c. So 1 plus 4 is 5. 5 take away 2 is 3. 5 take away another 2 is 1. 1 take away 2/3 leaves us with 1/3. So c is equal to 1/3. And that's your value for c. Therefore, the answer of the problem is y equals 1/3 x cubed, right? In other words, x cubed over 3 plus 1/2 x squared minus 2x plus 1/3. And that's the answer to this problem. Let's get into a second example. Alright, so let's take a look at this second example here. We're told that for a curve y equal f of x, d squared y over dx squared is equal to 6x minus 2. And given that y equals 11 and dy dx equals 10, when x is equal to 2, find the equation of the curve. So what does all of this mean? Let's interpret what is said here. What is d squared y over dx squared again? That is our second derivative. And we are told that that is equal to 6x minus 2. So if we were to integrate our second derivative, then that will give us our first derivative. Remember that if you have a function and you differentiate it, that gives you the derivative. If you then differentiate the derivative, that gives you the second derivative. Again, keep in mind that integration is just a reverse process of integration. So if you were to integrate the second derivative, then that will give you the first derivative. So let's see. Let's integrate our second derivative, d squared by dx squared, right? So we integrate the 6x minus 2 with respect to x. So if we integrate the second derivative, that will give us dy dx. And if we integrate 6x minus 2 with respect to x, we'll get 6x squared over 2, but 6 divided by 2 is 3, so that is just 3x squared. And then the integral of negative 2 is minus 2x. And then again, because this is an indefinite integral, do not forget your plus c. How do we proceed after this then? Well, let's see what other information are we told. We're told that dy dx is equal to 10 when x equals 2. So our derivative dy dx is equal to 10 when x is equal to 2. So we substitute those values in place of x and dy dx and we solve for this c. So 2 squared is 4, 3 times 4 is 12, 2 times 2 is 4, so that's minus 4 and plus c. Transposing, I have 10 minus 12 plus 4 is equal to c. Therefore, I get that this c is equal to 2, right? Because 10 plus 4 is 14, 14 take away 12 is 2. So that means that my derivative dy dx is equal to 3x squared minus 2x plus 2. How then can I get the equation of the curve? You might want to think, oh, that's the equation of the curve, we're done. We've integrated and we found the value of c. But no, we're not done yet. We have to integrate a second time. Because when we integrated the first time, all we got was the gradient function, dy dx. Now, how can we use the gradient function to find the original function itself? Well, we're told that y is equal to 11 when x is equal to 2. So if we were to integrate the dy dx with respect to x, then that will give us the function y. So what's the integral of 3x squared? That would be 3x cubed over 3, but 3 divided by 3 is 1, so that's simply x cubed. And then if we integrate minus 2x with respect to x, that would be minus 2x squared over 2, but the 2's cancel and we're just left with minus x squared. And the integral of positive 2 is 2x. And of course, don't forget your plus c. Alright? So we know that y is 11 when x is equal to 2. So that 2 cubed minus 2 squared plus 2 times 2 plus c. Alright? So when we work this out, we'll have 11 is equal to 8 minus 4 plus 4 plus c. Luckily for us, minus 4 plus 4 cancels out. I just have to transpose the 8. 11 take away 8 gives me 3. So I get that c is equal to 3. Therefore, the equation of the curve is y is equal to x cubed minus x squared plus 2x plus 3. So that's how you work out problems of these types, girls. You just have to integrate and read the problem to see what information is given and apply it.